The National Electrical Code, or NEC, defines an outlet as a point in the wiring system where current is taken to supply utilization equipment. In simpler terms, an outlet is where you plug something in to use electricity. This definition is crucial for understanding where arc fault circuit interrupter, or AFCI, protection is required. Let's consider an electrical panel, sometimes called a breaker box or load center. Its primary function is to distribute electrical power to various circuits throughout a building or home. The panel houses circuit breakers that protect these circuits from overloads and short circuits. However, the panel itself is not a point where current is directly taken to supply utilization equipment. Instead, it serves as a distribution point, feeding power to outlets and other devices that do supply utilization equipment. Therefore, according to the NEC definition, an electrical panel is not an outlet. Now let's address the specific requirement for AFCI protection in dwelling unit bedrooms as outlined in NEC section 210.12b. This section states that all branch circuits that supply 125-volt single-phase, 15 and 20 ampere outlets installed in dwelling unit bedrooms must be protected by an arc fault circuit interrupter listed to provide protection of the entire branch circuit. The key phrase here is outlets installed in dwelling unit bedrooms. Since an electrical panel is not considered an outlet, the requirement for AFCI protection does not extend to the panel itself, even if it is physically located in a bedroom. The AFCI protection is required for the branch circuits that feed the outlets within the bedroom, not for the panel that supplies those circuits. To further clarify, think about the flow of electricity. Power comes into the electrical panel from the utility company. Inside the panel, circuit breakers divide this power into individual circuits. These circuits then run to various outlets and other electrical devices throughout the building. The AFCI protection is installed at the beginning of each of these branch circuits, typically at the circuit breaker in the panel. This protects the entire circuit, including the wiring and any outlets connected to it, from arc faults. Arc faults are dangerous electrical conditions that can cause fires. They occur when electricity jumps between conductors, creating a spark. AFCIs are designed to detect these arc faults and quickly shut off the power to the circuit, preventing a fire from starting. The NEC mandates AFCI protection in bedrooms because these are areas where people are often sleeping and may be less aware of potential electrical hazards. Additionally, bedrooms often contain flammable materials such as bedding and clothing, which can easily ignite if an arc fault occurs. It is important to note that the NEC is a minimum standard, and local jurisdictions may have more stringent requirements. Always check with your local electrical inspector to ensure that you are complying with all applicable codes and regulations. Furthermore, it is crucial to use a qualified electrician for any electrical work, including the installation of AFCI protection. A qualified electrician will have the knowledge and experience to ensure that the work is done safely and in accordance with the NEC. In summary, an electrical panel is not considered an outlet according to the NEC definition. Therefore, it is not required to have AFCI protection even if it is located in a dwelling unit bedroom. The requirement for AFCI protection applies to the branch circuits that supply outlets in bedrooms, not to the panel itself. To understand the NEC requirements better, it is helpful to consider the different types of AFCIs. There are two main types: branch circuit AFCIs and outlet branch circuit AFCIs. Branch circuit AFCIs are installed in the electrical panel and protect the entire branch circuit, as mentioned earlier. Outlet branch circuit AFCIs are installed at the first outlet on the branch circuit and provide protection for the remainder of the circuit. The NEC typically requires branch circuit AFCIs for new construction and renovations. However, outlet branch circuit AFCIs may be permitted in some cases, such as when it is difficult to run new wiring to the electrical panel. When selecting an AFCI, it is important to choose one that is listed by a reputable testing laboratory, such as Underwriters Laboratories or all. This ensures that the AFCI has been tested and meets the applicable safety standards. The listing mark will be visible on the AFCI. In addition to AFCIs, there are other types of overcurrent protection devices that are commonly used in electrical systems, such as circuit breakers and fuses. Circuit breakers are electromechanical devices that automatically interrupt the flow of current when an overload or short circuit occurs. Fuses are similar to circuit breakers, but they use a fusible link that melts and breaks the circuit when an overcurrent occurs. Both circuit breakers and fuses are designed to protect electrical circuits and equipment from damage caused by overcurrents. However, they do not provide protection against arc faults. That is why AFCIs are required in addition to circuit breakers or fuses in certain locations. It is also important to understand the difference between AFCI protection and ground fault circuit interrupter, or GFCI protection. GFCIs are designed to protect people from electrical shock. They detect ground faults, which occur when current leaks from an electrical circuit to ground. GFCIs quickly shut off the power to the circuit when a ground fault is detected, preventing a person from being electrocuted. The NEC requires GFCI protection in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. While AFCIs and GFCIs both provide important safety protection, they protect against different types of electrical hazards. AFCIs protect against arc faults, which can cause fires, while GFCIs protect against ground faults, which can cause electrical shock. It is important to have both AFCI and GFCI protection in appropriate locations to ensure the safety of people and property. Another important aspect of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. A properly grounded electrical system helps to prevent electrical shock and fire hazards. The NEC specifies the requirements for grounding electrical systems, including the size and type of grounding conductors and the methods for connecting grounding electrodes. It is essential to follow these requirements carefully to ensure that the electrical system is properly grounded. Regular maintenance and inspection of electrical systems are also crucial for ensuring safety. Electrical systems should be inspected periodically by a qualified electrician to identify any potential problems such as loose connections, damaged wiring, or malfunctioning overcurrent protection devices. Any identified problems should be repaired promptly to prevent electrical hazards. In addition to professional inspections, homeowners can also perform some basic visual inspections of their electrical systems. Look for any signs of damage such as cracked outlets, frayed wiring, or discolored circuit breakers. If you notice any of these signs, contact a qualified electrician for further evaluation. Never attempt to repair electrical problems yourself unless you are a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock or fire. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are unsure about any aspect of electrical work, consult a qualified electrician. In conclusion, understanding the NEC definition of an outlet is crucial for determining where AFCI protection is required. The electrical panels are not considered outlets, so they are not required to have AFCI protection, even if they are located in dwelling unit bedrooms. The requirement for AFCI protection applies to the branch circuits that supply outlets in bedrooms, not to the panel itself. Always consult with a qualified electrician to ensure that your electrical system is safe and in compliance with the NEC and local codes. Remember that electrical safety is paramount, and it is essential to take all necessary precautions to prevent electrical hazards. Ignoring the NEC and safety measures can lead to serious consequences, including electrical shock, fire, and even death. Therefore, it is always best to err on the side of caution and seek professional help when dealing with electrical issues. Let's delve deeper into specific scenarios to solidify the understanding of AFCI requirement. Imagine a scenario where an electrical panel is located within a bedroom closet. Despite the panel's proximity to the bedroom space, the NEC does not mandate AFCI protection for the breakers within that panel supplying circuits outside of the bedroom. The critical factor remains the destination of the circuits power the outlets and devices within the bedroom itself. If a circuit breaker in that panel feeds a bedroom receptacle, that circuit must have AFCI protection. However, if a breaker feeds a hallway light, even though the panel is in the bedroom closet, AFCI protection is not required for the specific circuit. Now consider a situation where a single circuit powers both a bedroom and an adjacent hallway. In this case, the entire circuit needs AFCI protection. Because a portion of the circuit serves a bedroom outlet, the NEC mandates protection for the entire run. This highlights the importance of understanding the circuit's path and all the areas it serves when determining AFCI requirements. Let's discuss the types of outlets that necessitate AFCI protection in bedrooms. The NEC refers to 125-volt, single-phase, 15 and 20 ampere outlets. This encompasses standard wall receptacles where you would plug in lamps, phone chargers, and other typical household devices. It also includes lighting outlets designed for lamps, as well as any other point where electricity is drawn for utilization equipment within the bedroom. What about dedicated circuits for appliances within a bedroom, such as a window air conditioner unit? If the air conditioner plugs into a 125-volt, 15 or 20 ampere outlet, it requires AFCI protection. However, if the air conditioner is hardwired directly into a dedicated circuit, it may or may not require AFCI protection depending on the local jurisdiction's interpretation of the NEC. It's important to remember that the NEC is updated regularly and interpretations can vary. Always consult a local electrical inspector or qualified electrician for the most accurate and up-to-date information for your specific location. Furthermore, consider the evolution of AFCI technology. Early AFCIs were prone to nuisance tripping, shutting off circuits unnecessarily. This was often due to the AFCI misinterpreting normal electrical activity as arc faults. However, modern AFCIs are far more sophisticated and reliable, incorporating advanced algorithms to minimize nuisance tripping. Despite the improvements, nuisance tripping can still occur in some situations. This may be due to faulty appliances, damaged wiring, or other electrical issues. If you experience frequent nuisance tripping, it's important to investigate the cause and address any underlying problems. Simply replacing the AFCI with a standard circuit breaker is not a safe or code-compliant solution. The AFCI is there to protect against a real electrical hazard. It's also worth noting that AFCI protection is not a substitute for proper wiring practices. Even with AFCI protection, it's crucial to ensure that all wiring is installed correctly, with secure connections and appropriate insulation. Over time, wiring can deteriorate, leading to increased risk of arc faults. Regular inspections can help identify and address any potential wiring problems before they become hazardous. Moreover, consider the economic aspect of AFCI protection. AFCIs are generally more expensive than standard circuit breakers. This can add to the cost of new construction or renovations. However, the added cost is a small price to pay for the increased safety and protection that AFCI provides. The potential consequences of an arc fault, such as a fire, can be devastating, both financially and emotionally. In conclusion, while the NEC clearly defines that electrical panels are not outlets and therefore do not require AFCI protection simply due to their location, it is critical to understand the nuances of AFCI requirements for bedroom circuits. This includes knowing what constitutes an outlet, understanding the scope of protection for circuits serving bedrooms and adjacent areas, and staying informed about the latest AFCI technology and code updates. Prioritizing electrical safety and consulting with qualified professionals ensures the well-being of occupants and the integrity of electrical systems.